Good morning, students. Today we'll try to learn and find the areas and perimeter of various closed figures. Okay, so let us try to find the areas and perimeter. Okay, so now let us see how they are different of each and one closed figure. So one by one we'll discuss. First, now I'm talking about square. First, I'm talking about square. How it's look like. This is square. Let its side be A. We all know that square have all sides equal and all angles are 90 degree and its diagonals are also equal. So now if we need to find its area will be side square. Area will be side square. Okay, let's find this. Area will be side square. That is, if I take A, it will be A square. If I need to find its perimeter will be 4 into side. Its perimeter will be 4 into side, that is 4 into A, it will be 4A. Now, the third thing will be, now we have its diagonal. If I need to find its diagonal, it will be root 2A. Need to find the value of diagonal, it will be root 2A, but because we all know it's 90 degrees, so by applying this formula of Pythagoras theorem, we'll say A into A square plus A square is equal to hypotenuse square, that is diagonal will be root 2A. Now we'll move to next one, that is parallelogram. We'll have next thing is about parallelogram. How the parallelogram looks like. If I try to draw its figure, it will be something like, okay, so it is parallelogram. Here, if I need to find its area, that will be, how will find, that is base into height. Okay, so if I need to find the area, that is base into height, we all know that parallelogram, we have opposite sides parallel and equal, and we have opposite angles are also equal. That is about the parallelogram. Now if I move to rhombus, something like will be like this. If I say, see, rhombus and square have some similar properties, like rhombus also have sides equal. All sides equal in rhombus we have, but one difference is that in rhombus diagonals bisect each other at 90 degree. So if I need to find its area will be half into d1 into d2. That is how we able to find its area. Okay, so now the fourth figure, if I try to find, is, it will be trapezium. So how it looks like, if I try to draw the figure of trapezium, it will be like this. These two are heights perpendicular, opposite sides parallel. These two sides are equal but not parallel. If I write A and B, and that is height, we can easily find its area. So area of trapezium, how will you calculate? So we have the formula here. Area of trapezium, that is half into sum of two parallel sides into height. So that is the area of trapezium we able to find. Okay, so we have some closed figure of which we can find easily the area and the perimeter. These are the four closed figure I have taken, which is used not only in the present but also in future. Okay, so now let us move to another figure, that is fifth one. Now the fifth one is, let us take about an example of fifth one, that is fifth one will be of circle. Okay, now I am taking circle. Circle is a 2D figure, so we can easily find. Now if I need to find its area, if I need to find its area, how I can find area is, that is pi r square. Okay, now that is an area, and if I need to find its circumference, not a perimeter, we can say that is called circumference, and the circumference will be 2 pi r. Okay, so here we need to find the circumference instead of perimeter. Both are same but have different, name. Different name we can say, like circumference we have in circle, but in other we say to find the length of that is called the circumference. That is a perimeter now. Okay, so now let us move to the next thing is how to do it, how to find more area and perimeter of, no, it is no, we have instead of diagonal we have diameter. So how we find the diameter, that is 2r. So because the largest chord also we can say about the circle is this much, that is the diameter we have. So we can say that it is twice of radius is the diameter. So we can easily find that also. So we have this, the closed figure of which we can easily find the area and the perimeter. So we have more. So we'll find more and try to use them in the numerical. Okay. Now we'll try to find one more. We have closed figure, that is, we'll now take the triangle now. Okay, now we'll take the triangle that have three sides. So the next closed figure we have triangle. Okay, so now triangles, if I need to find its area now. Okay, this is a, now first write its name, that is the triangle. Okay, here we have base. If I say this is my height, now this is a triangle. If I need to find its area and perimeter, okay, perimeter if we will find. Now how to find area will be half into base into height. That is one of the formula to find the area of the triangle. And if we need to find the perimeter, then we need to add all sides of the triangle. Okay, all sides of the triangle. So we will say 3 into side. Well, we can multiply the 3 into the whole sides. If I need to find the area of an equilateral triangle, let us see. If the triangle is equilateral, then what will happen? So let us try its. Now in triangle we have so we can easily find that at least a closed figure have 3 sides or more. Okay, so in a triangle, if I take the equilateral triangle, if I take the equilateral triangle, then its perimeter will be 3 into a. Let us see, if I take the side, if I take the side a, then we can easily find its perimeter, that is 3 into side, plus if I need to find its area. What will be the formula for area? We have different formula, root 3 upon 4 into a square. So that is the area, and that is the, I can say, perimeter of an equilateral triangle. We all know that we have 3 types of triangles. Equilateral triangle is the isosceles triangle in which 2 sides are equal, and scalene triangle in which all sides are unequal. Okay, so we have 3 types of triangle, and if we need to find the area, we can find like this. Okay, so this, but we have other formulas also. Okay, I will go in detail. Like for example, if we need to find the area of a triangle using Heron's formula. So what is Heron's formula? Let us study about this, how to find the area of a triangle using the Heron's formula. Let us see how we can easily find it. Okay, so now let us find the area of a triangle using Heron's formula. Let us see what is this Heron's formula. Very simple formula. We use this for a triangle. If a triangle is given, okay, let us take A, B, C, and we need to find. So first we need to find its S. What is S? S is semi-perimeter. A, B, C, let us assume the three sides of a triangle. Then we find first semi-perimeter. A plus B plus C by 2. Okay, then what we can do is, let us try to find its formula. That is S into S minus A, S minus B, S minus C. So we have lots of, so finally we can easily find the area of a triangle using Heron's formula. Okay, using that Heron's formula we can easily find S is the side, S is the semi perimeter, and A, B, C are the sides which are given in this triangle. So likewise we can find very easily.